All right, guys, just a quick little introduction to matrices here. Matrix is the singular and matrices is the plural. Okay, so this is just a way for us to collect information. And so, like, you have a matrix here, and what it is we've got rows that go this way, and then we have columns that go up and down. Okay, so, and the way I always remember those and keep those straight is that columns on a building are the things that hold the building up. So the columns go up and down, the rows go left to right. And what's really cool about matrices is that they're a good way to store information efficiently, and you can actually use them to solve systems of equations with 3, 4, 5, 6 variables. I mean, really as many variables as you want. So they're a really helpful mathematical structure. So I'm not going to read all this to you guys. You guys can read, but I just wanted to hit on some basic things. When we talk about a matrix, this is really important. We're gonna call each thing in there an entry. So that's what this says. If I wanted to go to row 2, column 1, so row 2, column 1, I would say a row 2, column 1. We'll write it like that, and then what we'll do is we'll go to row 2, which is here, and then column 1, which is here, and then that 6 will be the entry that I'm referring to. And this is really, really, really important. When you're finding dimensions, you always do rows first, then columns. So if I say A2, 3, it's going to be row 2, column 3. So it would be -1 there, okay? So when we talk about the dimensions of a matrix, we're just talking about how many rows and columns does it have, right? So like in this matrix, it has 2 rows and it has 3 columns. So M is a 2 by 3 matrix. Okay, so I'll let you guys fill those out. And then what they want you to do for like number 5 here is they want you to give the entry indicated at row 1, column 3, right? That's what M13 means. So row 1, column 3 would be right here. It would be the number 3. So literally all we're going to say here is the number 3. Okay, so that's what they want us to do for that. I'm now going to flip to the second page. So you can imagine if you have a couple matrices that are the same dimensions, so they have the same number of rows and columns, like these two right here. These are both 2 row by 3 column matrices. If you wanted to add matrices, just make sure that they have the same dimension, otherwise it wouldn't make sense to add. And then what you do is literally, this is super easy, you just take each entry that happens to be in a certain row and column, so like row 1, column 1, and row 1, column 1, you're just going to add those 2 numbers together. So you're basically just combining the entries. So -3 plus 5, which you can see right here, is 2. And then 0 plus -2 is -2. And then 2 plus 2 is 4. So that's how you add and subtract matrices. Do keep in mind that if you subtract a matrix, that you just pay really careful attention to the signs. So let's look at 14 here. So we've got A minus B. So -2, 0, 1, 5, -7, 8. When you subtract matrix B, which is 5, 7, 1, 0, 2, -8, when you subtract this, just make sure that you mind the signs. So this is going to be equal to, the result will be a 2 by 3 matrix, and let's see, okay, so we got -2 minus 5, so -2 minus 5 is -7, then we have 0 minus 7, 0 minus 7 will be -7, then we've got 1 minus 1, that'll give us 0, 5 minus 0, that'll give us 5, -7 minus 2, so -7 minus 2 will give us -9, and then here's where you got to be careful. 8 minus -8 is really 8 plus 8, so that'll give us 16. So just be really careful here when you do these. And you can also, if you have 3 matrices here, all you're going to do is take A and then add it to B and then add A again. So sometimes people will write it all out. Sometimes people, they see a couple A's here and they're like, well, I'm just going to double the entries in A. That's totally fine. That works. We're actually going to talk about that here in just a sec. Speaking of multiplying things, so now I'm on the third page. This is called scalar multiplication. And all that means is that we're just scaling by a certain number. So what we're going to do is we're going to take a matrix, Okay, so like right here we have a 3-row by 3-column matrix, and we are going to multiply. It's asking us to find negative 2a. And by the way, so if I say capital, we usually use capital letters to denote a matrix. If I have a capital A here, and this is the matrix, this is a 3 by 3. When it says negative 2a, it's literally just this collection of items all multiplied by negative 2. So you'll just come in here and the way that we write this out, longhand, is like this, multiply by negative 2, and then you don't necessarily have to go in and show every single multiplication in here like they do, like all these multiplications. But I would love if you would write this, and then you could write this, right? So 3 times negative 2 is obviously negative 6. 2 times negative 2 is negative 4. 0 times negative 2 is 0, and so on and so forth. So you can just fill in that. So this right here, this resulting matrix is negative 2 times A, okay? So these are pretty straightforward. Like this one is going to be half of J. So where's J? J's right here. And if you have half of that, you'll just take half of everything in here. You can either write decimals or fractions. Personally, I'm more of a fraction person. I do not recommend decimals, but you won't be wrong if you put them in there. Okay, let's talk strategy real quick on 23. 23 wants you to do 1/4 of B minus 2A. So it's up to you how you do the order on this, but just make sure that you, like if it was me, I would probably figure out what negative 2A is, and then I would do B minus, I guess really it'd be B plus negative 2A, and then I would take 1/4 of that. So you may have like several steps of work, right? You might want to write out negative 2a right here, and then you might want to right here do b plus negative 2a, and then over here you do 1/4 of that. Okay, so just be careful, make sure you mind these negative signs. Remember, in algebra, a negative sign gets distributed to both terms. So this negative sign here would go to both the negative b and the negative a. So really, what is this? This is 2a plus b plus a. So really, if you wanted to just condense this down into 3a plus b and then do it that way, you could totally do that. Okay, so this is the last page here. These are just kind of, you're going to have to do some problem solving now that you know how to add and subtract and do scalar multiplication of matrices. So like on this one, you have a 2 by 2 and then a 2 by 2, and the result is a 2 by 2 when you add them. This one's just saying, hey, if you took x plus 2 and you added 3 to it, wouldn't that give you 7, right? If you take the first row, first column entry, plus first row, first column entry, that would give you first row, first column result. So you're going to have to use some logic here to figure out how to solve these.